There's a logistics network that already reaches almost everywhere, connecting industrial sites, cities, and ports across an entire continent. It can store vast amounts of energy. It's been doing so for decades. That network is the gas grid. Electricity decarbonisation is progressing well, but the hard-to-electrify sectors haven't moved fast. Industrial heat, steel, glass, shipping, aviation. Could biomethane be part of the answer? Made from organic waste and agricultural byproducts, it produces a natural gas blend, and the argument goes the gas network is already built. My guest today is Philipp Lukas, founder and CEO of Future Biogas, someone who spent his career making the case for biomethane. This episode is about whether the gas grid becomes a clean energy asset or gets left behind. Before we move on, a lot of people listening will have follow-up questions after an episode like this. Those are exactly the questions Modo Energy's AI analyst is built for. Try it out now, link in the description. Now, let's jump in. Hello, Philipp, and welcome to Transmission.
Hi, Ed. It's great to be here.
Excellent. And let's kick off straight away. So what is the one thing that everyone gets wrong about biogas?
Oh, I think the one thing everybody gets wrong is that they consider biogas to be a niche waste treatment technology rather than potentially a massive part of the solution for high heat applications and difficult to decarbonize sectors.
Okay, interesting. I think I fall into that gap. So let's see.
Excellent.
Let's do a pulse check.
it.
Let's do a pulse check when we get to the end. Okay, great. So let's start off with the basics. We've just talked about biogas. Some people have no idea what that is, but they will have seen these little sort of green domes popping up in different places over the countryside. Yep. Like, what is it? How does it work?
Yep. Fundamentally, it's just digesting organic material, and that can be anything, to produce methane. And methane is effectively a one-for-one substitute for natural gas. It is what natural gas is made of. And the way you go about it is you take organic wastes, food waste, animal manures, sewage sludge, or you take a whole raft of agricultural byproducts or purpose-grown energy crops, and you put them in those pots that you talked about, and you hold them there at sort of 35 to 45 degrees C, and a natural reaction happens, anaerobic digestion, it's called, the digestion in the absence of air, that effectively produces methane and carbon dioxide, roughly in a sort of 60-40, 50-50 balance, depending on what the input materials are. And that's how you make biogas.
Okay. And then that kind of the big balloon that sits on top.
Bang on.
What does that do?
That's a store for the gas. So the big balloon often has a second one inside that rises and falls, like an old school gasometer for those in their 50s and 60s who can still remember that, right? But effectively just a store.
Yeah.
And then you take the gas and you either turn it into electricity or you scrub it up to pipeline quality and bang it into the gas network.
And for those who aren't familiar with the gasometer, but like the heat pumps, you can also you get these kind of balloons that do something similar inside a heat pump process to manage pressure.
To manage pressure, exactly. It's just and for us, it's just a storage mechanism.
Okay, and so that's what it is. And when it comes out of that sort of anaerobic digestion, is that at the point of being like exactly equivalent to natural gas, or is that
at the point it comes out of the digestion? As I say, half of it roughly is carbon dioxide because it's a fermentation, and because it's a fermentation, it's analogous to making beer, where you get the output product alcohol and carbon dioxide, the bubbles in your beer, right? But in our case, we get methane and carbon dioxide, and we then need to get the carbon dioxide out if we want to inject it into the gas grid. Okay.
So it has to kind of be scrubbed of the carbon dioxide to then go into the grid.
The common way of doing that these days is to stick it through a gas upgrade unit, which is basically a sieve that is fine enough to distinguish between a methane molecule, CH4, and a carbon dioxide molecule, CO2, right?
Yeah.
So holes that are so small, a membrane that is so fine that you can effectively sieve those two into their component parts and end up with 100% methane on one side and 100% carbon dioxide on the other.
Okay, and when people use this, do they generally tend to use the biogas or do they tend to use the methane?
So historically, particularly in Europe, we have gone down the route of making electricity on site. In the last 10 years, we have, as an industry across Europe, refocused on what's called biomethane, which is effectively where you scrub up the gas, take out the carbon dioxide, and stick it in the gas grid. And there's a variety of reasons for that, not least the fact that that is, from an energy point of view, the more efficient thing to do. Making electricity on site is great, but you lose a lot as heat. It's quite inefficient, whereas sticking it into the gas grid allows you to transport it anywhere on the gas network, which, remember, across Europe is connected. Virtually all European countries, whether they're in the EU or not, are connected on the gas grid. And then you can use it for a whole load of difficult to decarbonize stuff like high temperature applications and vehicle fuels and so forth.
Okay. And are there more uses than that? So obviously some gets used for generating electricity, some goes into the grid. Does some also get used on these sites? So let's say you're a sewage works, or you're a very large farm and you've got sort of organic product that's going through the anaerobic digestion process. Could you use that for sort of heating?
You absolutely can, and people do. So some people use a little bit of it for heating, or quite a lot of it for heating. Some people use it to make their own electricity on site. Some people compress it and use it as vehicle fuel. That's, people use it for haulage for lorries. People use it for tractors and all sorts of uses. All of that's perfectly valid. Gas is an incredibly versatile energy carrier. And the great thing about gas compared to electricity is also that it's very easy to store. The gas network that we all know but don't see because it's all underground transports and stores a vast amount of energy.
And let's come on to that in a second, but just so we get a kind of an idea of like what the sort of main uses are, and kind of like which one do you like going forward? Because as you said, like the electricity generation was a big one historically, but maybe less so these days. So if you kind of had to like rank the top use of sort of biogas and then kind of working your way down, how would you state that?
Yeah, I mean, as you know, and as you've discussed with lots of people on this podcast, no doubt, electricity has now become something that we make incredibly well from renewable sources. Solar, wind, we then store it in batteries. We're probably going to build more nuclear. We're definitely going to build more hydro, et cetera, right? So from an electricity point of view, we've done incredibly well. And that's where, frankly, in Europe particularly, most of the decarbonizations happened in the last 20, 30 years.
Yeah.
That takes us on to the much more difficult to decarbonize stuff, particularly heat. And I don't mean low-grade heat that you can do with heat pumps. You're in my house or flat or whatever.
So you're imagining sort of under 100 degrees.
Yeah, exactly. That sort of stuff we can easily do with electric in future. Just need a bit more electric, clearly. What gas is going to be important for are things like the foundation industries, bricks, glass, steel, the process chemistry, making all the things that we need in our lives in big chemicals plants around Europe and around the world. We're also going to need it for shipping, because that's a really knotty one to decarbonize, and we want to get away from heavy bunker, which is filthy stuff that we use at the moment to power ships, and probably in aviation. I think that gas and biomethane probably have a significant role to play in the production of sustainable aviation fuels, liquid replacements for jet fuel.
Okay, so a wide range of topics. I don't think your liquid jet fuel was the top of the list, even though it ended to be the last thing you were talking about.
No.
But really, I think top of your list is probably the use of gas in high temperature activities, right? That feels like top of your list. Okay, I don't want to.
No. I mean, listen. At the end of the day, the situation isn't clear. We have targets on aviation fuel. And actually for 2030, 35, they're quite challenging, right? We have targets for decarbonizing shipping, and those too are starting to bite. So it may be that a lot of it moves in that direction because we don't yet have quite such stringent targets for a lot of the foundation industries. What we have there is emissions trading schemes. We have, a price for carbon. But that's not nearly high enough yet to push people towards biomethane, partly because in a lot of the real foundation industries, energy is such a huge part of their cost base, right? If you look at, for instance, making glass, glass makers basically buy sand, white sand, and a load of gas and turn that into glass, right? That means that the gas price is a huge headache for them. In other areas, including shipping, it's maybe not quite as painful. It'll be the market and the regulations that we push that dictate where the biomethane goes. From my point of view as a producer, I don't really mind where it goes. Ultimately, I just want to see lots of it on the grid, and I think there's an opportunity to make loads of it.
Okay, let's come back to the opportunity to make loads of it in a moment, just to kind of so we can work out the scales of the volume. But in just to reference one thing you said, which was the natural gas plus the carbon cost. So the price of natural gas today plus the carbon cost isn't yet high enough to encourage people to use biomethane directly.
Yeah.
Encourages the question, well, look, let's find out about the costs of this.
Yeah.
So what's the difference in the cost between natural gas today and biomethane today?
So let's go with the European market, right? Broadly speaking, and the UK market's not that dissimilar. Gas is currently today trading at somewhere around 42 pounds a megawatt hour, right? And to make fully unsubsidized gas, you probably need to be paid 2.5 times that.
Okay.
Right? That's because obviously fossil gas doesn't pay much of a penalty for its pollution. Oh. To be fair, those industries that pay under the EU ETS, who pay for their carbon emissions, will be paying around £80 a tonne for their CO2. 80, 90 pounds is sort of the price at the moment. That, translated back to the gas price, means they're actually not paying 40 euros for a megawatt hour. They're actually probably closer to 60 euros a megawatt hour, all in with the, if you like, the emissions penalty.
Yeah.
But that's still 60 versus, say, 100.
Okay.
So you've got that gap that needs closing. And in our view, that gap needs closing by a couple of things. One, the carbon price will rise over time. Definitely, it'll get more expensive to pollute. Second, there'll be more industries that are pulled into that trading scheme and will push that up. But third, we just need to get better at using less. Okay. And get more efficient at using. We've gotten, as a world, a bit lazy in our energy efficiency because energy's been so cheap.
So let's say I'm a consumer, right? And you mentioned EU ETS, which is the emissions trading scheme, which is essentially how people account for the carbon that they're using in the gas that they're using. Just because people may not have heard of that before. And so if I'm a consumer of this, let's say I'm at Glassworks, I can either get natural gas and sort of pay for the emissions trading scheme, or I can go biomethane. Yeah. In today's world, why would someone go down the biomethane route?
So the people we're talking to talk about unsubsidized gas, and obviously our first deal in that space was with AstraZeneca. We built a plant effectively to supply them with gas in the UK and launched that around about a year ago. That was a decision by AstraZeneca to go net zero. And then they set themselves a net zero target of about 4.5 weeks ago, which is pretty impressive. All right, they said they'd be scope 1 and 2 net zero by the end of 2025, and barring about 1 or 2%, they did it.
And so that's all of their electricity and all gas. Of their gas, critically.
Yeah, which is incredible when you think about it, and absolutely a lead that others need to follow. And they said when they first came to the market with this idea 5 years ago, they said, look, we want to do this properly. We want to do this in a way that's greenwash proof. We want to do this in a way that carries full additionality, as the jargon goes, which is to say that we've paid for it rather than the taxpayer subsidizing it.
Okay.
And in the energy transition, there is a place for the taxpayer to help, to kickstart industries, to subsidize. Yeah. We wouldn't have a business. I wouldn't have anything to do if there hadn't been subsidy, because we run a bunch of plants that were supported 10 years ago by subsidy. But there is now also obviously a world where people start paying the full price for green electricity and green gas directly from, if you like, not directly by a wire, but directly from the producer, whether that's offshore wind or whether that's solar parks, or whether in our case and with AstraZeneca, that's gas that we inject into the grid. And we inject it in the middle of Lincolnshire, which is sort of in the middle of the east of England. But AstraZeneca are using it at 3 different production locations across the UK, Cambridge, Macclesfield and Liverpool, which are nowhere near Lincolnshire.
Yes.
But the beauty of it is the gas grid connects all of those. So while they're not using our gas,
the exact molecule is not the right one. It's still the one molecule goes in here and one molecule
there is a
goes
shipper
out.
in the middle who is mass balancing it all and making sure that we inject and they take out the exact same amount. Yeah. And that's no different to any power purchase agreement for offshore wind or for solar or anything else. You know, you're never actually using the electron that's come off a wind farm in the North Sea.
Yeah, of course. Well, someone is.
Someone is, yeah.
So I think this is probably a really nice time to bring up that question, right? So you've moved the conversation towards the gas grid and the fact that it is a phenomenon
Yep.
in GB today.
Yep.
Obviously, as time moves on and we electrify more of the system, so we have fewer gas turbines, we have less gas heating in homes, there's a real discussion to happen around gas networks and what do we do with them?
Yep.
And do we keep on running them or do we retire parts of them?
Yep.
How do you see biomethane working in that world? Is there a world in which we don't use the sort of gas pipelines as they are today, and there's another way of delivering this? Or how do you see it?
Well, it's an interesting story because obviously the mood music around this has changed fundamentally in the last 5 and 10 years, right? We've had in the last 5 years in particular huge interest in hydrogen, which has sort of abated somewhat now, and it was touted as the alternative gas in the system, and no longer is. We're now at a point where I think people have realized that the gas grid is a valuable asset and we do want to keep it, not least because it is the biggest battery in the country by far and away. You sometimes hear that, in a cold winter's week, we have 8 days of gas storage. When you think about it, that is a huge amount of energy. That's 8 days of keeping the country warm and lit when the beast from the east is here, when it's freezing cold outside. And what we think is going to happen, and I think the gas networks are moving in that direction as well, in the UK, but also across Europe, the distribution and the transmission networks are all moving in the direction of there will be less gas going through the network. At the margins of the network, there will be less people connected over time. So you will have, homes switching to heat pumps. You'll have businesses switching to new ways of doing whatever they do with gas at the moment. But there will still be a lot of consumers connected in 2040 and in 2050 and beyond. And it then becomes a question of how much gas are you using then? So in numbers terms, right, we use in the UK at the moment around 700 terawatt hours a year of gas. Around 45% of that goes to making electricity. And obviously, the more wind farms and solar and nuclear and whatnot we build, the less gas-fired power stations we're going to have. So that will shrink away quite rapidly, given the build-out of gigawatts of offshore wind. And then what we'll see is people getting more efficient over time in their use of gas. And AstraZeneca, again, are a brilliant example. Then when they originally came to us, they said, we use 350-odd gigawatt hours a year. And actually, they've probably reduced that by over 60% now through insulation, upgrading, electrification, et cetera, which is all good, right?
And you've also mentioned heat pumps as well on like the domestic scale.
Exactly. So we will, common view amongst industry, gas networks, the ministry here, DESNZ, the Department for Energy and Net Zero, is probably that will be sort of somewhere between 150 and 250 terawatt hours by 2050. Right? So a third of what we're using today, give or take, right? Possibly less. And then you go, well, how much of that could biomethane do? And that's where the industry has published some papers recently, and we've been working with NESO, who are the National Energy System Operator, the sort of strategic thinker in the UK about the future of the energy networks. And I think we've all reached a conclusion that in order to get to net zero, we probably need 50 or 60 terawatt hours to come from biomethane, which is roughly 10 times as much as we produce today. But the potential is possibly to make up to twice that.
Okay.
So a really significant chunk. And this is why my answer to your first question was, it's not a niche application to treat waste. It's a major part of the energy transition. If we could make 60 to 100 terawatt hours, that could be half or more of our total gas use in 2050 for stuff that we really can't do without in the UK, whether that's cooking food or whether that's making pharmaceuticals or whether that's making any of those foundation industry things or all the process chemistry to make, the building blocks of life.
There's loads to unpack in here, right? Let's probably the most sort of, I think, and make it academically interesting part is the gas grid piece. Let's start there. So 700 terawatt hours today, potentially 200 terawatt hours in the future at some point. I agree with you that lots of forecasts are wrong.
Every forecast is wrong.
Yes, indeed. And so let's just take it thematically, right? But when you do that, I could see a world in which some areas progress faster on the electrification front, and all of a sudden there's parts of the gas network that just aren't getting much utilization. You just don't need. Do you see those parts of the gas network? Do you see them? Do you see sort of people trimming it to get it to be fit for purpose, or do you think it's kind of like the whole thing just exists?
I can't speak for the gas network's business model, but you can imagine, right, that at the end of the gas network, if you're talking about rural gas use and villages and so forth, there will come a point when, you know, there were 50 or 60 connections and then there are 5 or 6. You know, you'll probably get people starting to make efforts to work out why the last 4 or 5 people aren't. And it'll be insulation, it'll be old properties, it'll be, you know, I'm scared of heat pumps. I've heard a load of, you know, bad news about them. But that's all solvable, right? And you will get to the point where it'll be in the interests of whoever's running the network to shrink it, probably. You know? Because at the moment, the network is a little bit like the blood system in your body, right? Some big arteries and then a whole load of tiny little capillaries running all the way to your fingertips. And ultimately, the fingertips are the expensive bits to maintain, and you probably want to pull back. So
from a cost to consumer perspective, someone, NESO, Ofgem, will sit down and go, look, actually, should we maintain this £1 million
There is a consultation at Ofgem going on about that at the moment, albeit that where Ofgem is at the moment is there's still, in the UK at least, there's still discussion about turning the whole gas network off.
Yes.
Because there's still some sentiment amongst government and civil service and certain parts of society that actually we can electrify everything. But economically electrifying everything, as you've probably had discussions on this show before with people, economically electrifying everything just isn't possible. Some things, you know, once you get to high temperatures or once you get to making marine fuels or whatever, starting with a gaseous fuel is a hell of a lot cheaper than starting with an electron.
Yeah, there are definitely challenges. I think we definitely see a world in which there are some gas units that run for longer in a strategic reserve type manner. It's one of the big electrification questions.
Are you talking about the Dunkelflaute?
I'm talking about Dunkelflaute.
The dark doldrums, yes.
A week when you have low wind, low solar, and you have high electricity demand because people are running heat pumps. And so there is that challenge.
Oh, there will absolutely be backup gas generation there. And it may even be unabated backup generation, because we may only, depending on who you look at in academia, we may only need it for 2 or 3 weeks a year.
Well, this is just the thing, right?
You know, it'll be a rounding error, but an important one.
Yes. Are we better off trying to sweat assets that we have for longer, given we have the capex, and run unabated gas, or and then the money saved versus trying to put a solution in place for that, the money saved for that, use that in some carbon reduction way, right? So if you can save a kilogram of carbon in one way and it costs you £200, you can save a kilogram of carbon another way and it costs you £100, then should we have a bit of systems thinking about this?
I'm a slightly unconventional energy salesman in the sense that actually what I want my clients to do is use less. You know, the cheapest kilowatt hour is the one you don't use. And that's one of the key messages that we've always failed to put right at the top. It's like the recycling pyramid, you know, reuse, recycle, and then throw away or whatever.
Whichever one the last one was. We actually haven't had the recycling pyramid on.
But you know, in energy terms, the first thing we always should think about is how not to use it. What can we do to our process? And that's where the sort of really progressive front end companies are starting, and the ones you hear about in the press that are really thinking about this are obviously the tech companies who at the moment have a bit of a headache because of the build out of data centers, but also then people like the pharmaceuticals, people like some of the food industry, people who have a brand image, who are really, really keen to ensure that they're seen to be going green and are doing it the right way and are not free riding off the taxpayer. But a lot of them have realized that the first thing they need to do is actually look at their processes and go, well, what can I do? You know, where can I spend money here to use less energy or to use it more efficiently or to flip to electricity, because I can see that that's going to be easier to decarbonize and probably cheaper in the future.
Yeah. So let's carry on that gas idea. So we get to the world where not all of the gas network exists as it does today. Is there then a part of the sort of biomethane story where you're saying, well, look, instead of trying to inject it into the grid, I'm going to have to try and deliver it in another way? Or would you suggest that kind of the the biomethane story becomes one that's much more of sort of local use. So
let's take it from
comes out on site and then gets used on that same site, and there's no sort of transport.
No, I think we're going to stick with the network, and I'll tell you for why. I think, and this applies to particularly obviously the whole of the European market. Most of Europe, and particularly the UK, has spent 150 years investing in a gas network. And in the UK and a lot of the rest of Europe, we have spent the last 20, 30 years replacing the remaining cast iron pipes with brand new plastic pipes, the yellow stuff you see when you're stuck in roadworks, right?
Yeah.
Those have a design life of north of 100 years, right? And once they're in the ground, the cost of maintaining them, particularly the sort of larger gauge ones over longer distances, is not that great. So once you've connected a biomethane plant, even if it's in a rural environment, actually keeping that connected to the network, I don't think is going to drive the costs up that much. I mean, very happy for Cadent or Northern Gas Networks or somebody to correct me, but I think
we have opportunity for a gas network owner to come on and to talk about the economics of their gas plant.
Exactly, but I think we have 130, 140 biomethane plants in the UK today, which is quite big by European standards. Ours are also quite big by the standards of biogas plants. We're behind the Germans and the French. The French in particular have built out 900 in the last 5 or 6 years. Smaller, but lots of them. The Italian market has a lot of biomethane plants and is growing very strongly at the moment.
Let's try and put some numbers on this, right? So maybe I'll just quote back some numbers you had earlier. So 700 terawatt hours was the total gas number. You then said around, I think you said it was a multiplication of the number today. I think going backwards on that calculation was about 5.
Yeah, we've got about 5 or 6 terawatt hours connected in the UK today.
5 or 6, okay. Yeah. So like, that's nice for me. It's easy maths. It's 1%.
Yeah.
So that's. I mean, if the only thing I'm here for is easy maths, really. So around 1% of gas today comes from biomethane. It feels like it's a very hard thing to say that we're going to roll that 1% into a future operating model of gas. It feels like if I had to look at where the volumes come from and I had to bet, I would say, well, look, we're just going to keep on running natural gas into the system, keep on paying a carbon price for it. And biomethane is going to remain in those kind of niche places that it does today, which is, as you said at the start, sewage, organic waste, etc. How would you convince someone that the road from 5 terawatt hours to, say, 60 terawatt hours is doable?
So, I mean, first of all, in percentage terms, obviously, you're helped by the fact that what you're going to see is the demand side and the supply side move, right?
Yes.
So the supply side is me saying, and the industry saying, we think we can do 10 times this. But the demand side is everyone saying we're not going to be using 700, we're going to be using 200 or less, right? So in percentage terms, obviously, that helps hugely because you go from 1% to 30% rather than from 1% to 10%. In terms of the industry, we have recently done a whole series of reports as a body called the Green Gas Task Force in the UK. And one of those reports was around feedstock availability. And it demonstrated that and this is partly because the United Kingdom has a lot of opportunity to do this in its agricultural base. There is a huge opportunity to put biogas production onto the farm to grow crops as part of a sustainable rotation that helps the farm reduce its fossil fuel inputs, less diesel, less fertilizer, less sprays, that helps the farm build soil organic matter, that helps the farm build its resilience to climate change, at the same time as delivering 1 in 3, 1 in 4, 1 in 5 years, a crop into a biogas plant rather than a food crop.
Yeah, this
helps profitability, helps the resilience of the farm, and helps us make gas for the grid.
I think this is a really interesting part, right? So maybe kind of going slightly afield to say the US, and you kind of hear the stories about ethanol, and you look at like the land required to produce like a unit of energy of ethanol versus actually what a solar panel can do. And I haven't got the stats in front of me, but it's always really remarkable, right? It's always something like 10 times or 100 times more space is required to grow the crop rather than just run a PV panel. And I feel like the distinction you made there is probably quite an important one. So if I was to suggest to someone, we're going to grow a load of maize, let's say, and we're going to essentially ferment that, and that's going to be our plan, I would say, well, I'm not that happy about that because I don't really like a single crop dominating a field. And I don't think it's great use of farmland. But if you were to say to me, it's every 5 years and it's part of the sort of fallow process of the land, then that's a very different piece to the maize. Is that a distinction that's being made?
Really valid distinction. So first thing to remember is when you make ethanol, and frankly, biodiesel is not dissimilar, you're only ever using the seed, if you like. Okay. So you make ethanol from wheat or from corn, but you're only ever using the corn cob, and even then only the kernels, right? The bit you make popcorn out of. And for wheat, and we have a wheat ethanol production in the UK, you just use the grain. We take the whole plant. So we take oodles more energy off an acre because we digest the entire plant. The second bit to remember is that we return all of those nutrients back to the field the following year. None of our feedstock ever travels more than 10 or 15 miles. It's all very local.
And we've not talked about this, right? That's because the process of anaerobic digestion, you chuck it all in under the balloon. You get out CO2 and methane, and then you also get an end product, which is the thing that has digested.
What's left over.
Which is like a manure type
is effectively a liquid fertilizer.
Okay.
Yeah. It's you can split it into a solid and liquid fraction, but for the sake of argument, let's just say it's all of the liquid that's left over.
That sounds like a horrendously messy job.
It is a little bit, yeah. But I mean, 5 years ago for Red Nose Day, I took a bath in Digestate just for charity. Yeah.
Oh, well, we'll put a link in the comments.
There is a photo out there somewhere. I'll let you have it. I wore a very nice stripy Victorian bathing suit. But no, it's a great fertilizer. It's a brilliant organic fertilizer that goes back on the crops, that is a real turbocharge, and all of the nutrients that have come off the field with the maize, not just the classic farming nutrients, NP and K, but also all of the trace elements and everything else goes back to the field.
NP and K being sodium, potassium,
and nitrogen, ammonium,
phosphates.
nitrogen, ammonium. Potash, phosphate, and potassium. Yeah, so the three
nitrogen,
key
phosphate, and potassium.
Yeah,
Right.
or kalium in German, hence the K.
Okay, there we go.
So those are the key agricultural fertilizers. But obviously, there's a load of nutrients that go with that, and they all go around in a circle. And that's one of the beauties of anaerobic digestion. The other part of it is that we don't do fallow. You said fallow earlier. I mean, we don't do bare soils anymore. The way to grow sustainably is to make sure you always have something green in the field. So cover crops, break crops, all those sorts of things. And the way we farm now, particularly in the United Kingdom, there are less and less options very often. Chemistry is disappearing. Food choices are changing. One of the ethanol plants in the UK has just shut. So demand for wheat has fallen. We will probably in the next 20, 30 years see a reduction in the amount of feed grown for animals. I mean, it's a whole different discussion that is, a huge subject. But as you know, 75% of the world's grains and pulses are grown to feed animals, not humans. So agriculture is changing massively. And in the United Kingdom in particular, what with subsidies being entirely focused on environmental outcomes these days, the sustainable farming initiatives and so forth, all of that means that there are many, many more opportunities for farmers to profitably grow crops for biogas in their rotation while still boosting their production of food crops, creating resilience on the farm, and reducing their fossil inputs. And you can't say that about corn for ethanol or oil seeds for biodiesel or wheat for ethanol. It's just, those are just crops where you put materials in, you take stuff off, and nothing comes back. There's no benefit other than some cash to the farm.
Yeah. Interesting. I had two more questions I wanted to run through. So one was around the feed stock that goes into it. How variable is that? So when we've got those small little green bins that we're putting our orange peel into, is that kind of is this where it's ending up?
So let's talk about the 3 or 4 different inputs that go into biogas. So the water companies have a bunch of biogas plants in which they digest sewage sludge, right? That's the stuff that comes down the pipe from you and me when we flush the toilet. And that's a perfectly sensible thing to do. The issue the water companies and others have at the moment is that there's a lot of stuff that comes down that pipe that we may not want to put on fields.
But that was going to create biogas anyway.
So yeah, it has been for many, many years. Right.
Okay. And so once that's got methane in it, we don't want methane getting into the atmosphere. So capturing that is a sensible thing to do.
Exactly. Then you've got food waste, the stuff that you and I collect in a caddy and that goes off to biogas plants. Now, we have in the United Kingdom almost enough capacity to deal with all our food waste. What we actually need to get on with is collecting the rest of it, which we're now doing.
Okay.
DEFRA's Simpler Recycling, launched not too long ago, has brought new volumes on. They will be taken up by a series of existing and a couple of new build plants, and we will then turn all of our food waste into a valuable fertilizer plus the gas. But that's obviously a limited amount.
Yes.
Because we want to reduce the amount of food waste we produce.
And just to kind of comment on the sort of economics of that, it feels like if we had to send lorries around to collect orange peels from individual houses to then make methane as the end product, the economics of it wouldn't stack up. But the economics of collecting organic food waste comes from the value of taking away waste from home.
It comes from a number of facts. First of all, I mean, I live in near Guildford, and our food waste collection happens at the same time as our other waste collection. They just have a lorry that has 2 caddies on it, right? And so it's not that much extra effort. I put it in a separate bin. They pick that up, stick it in one end of the lorry, and then they stick the other waste in the other end of the lorry.
We haven't had recycling schedules being talked about. We have a different recycling schedule.
There you go. There is, and it is different all over the place, but actually from a collection point of view, there is a little bit of extra cost, but it's not that much. And the advantage you get is, of course, you take it out of the waste stream where it might otherwise digest and just compost or digest and create methane, in another way. And then you put it into a food waste plant. You need a separate front end to separate out the bits that people accidentally, the odd Rolex that people drop into their food waste caddy and then can't find anymore, or cutlery or whatever. But the food waste market is pretty well developed, and the economics are pretty well understood. Difficult in really rural environments, and difficult in cities because people don't like smelly food waste standing around. But there are solutions for that. You look at other European capitals, and they install centralized food waste bins on street corners where people can go and tip it in. Those sorts of things.
And it's just so Hans says, it's a mixed thing, right? So there's some value in the biogas that comes out, but there's also value in taking the waste away, right?
Absolutely.
So it's kind of a combination of those two revenue streams.
Absolutely. So that's sewage and food waste. Then you've got animal manures, right? That's obviously a big source of methane. Not as big as the burping from the cow, enteric emissions as it's known. The cow burping is the biggest issue, but there is obviously the big issue around slurries and so forth. That in the United Kingdom is something we haven't yet got enough of. We'll have more of. But of course, one of the things we have in the UK is a lot of animals who stand outside.
Okay.
And short of fitting them with nappies, we're never going to collect their poop. So pigs in fields, cows in fields, great thing. Actually, probably where they should be in our sort of climate. But in operations where everything is inside, so chickens, and on lots of places in Europe where you have pigs inside, Denmark is a classic example. They're all housed. Great, you can collect all of that manure and you can make biogas out of it and return it to the fields. Great way of decarbonising agriculture.
And I think part of where I want to go on that is sort of what's then the availability of how often does that thing break because there's a gold Rolex inside it?
So it's all down to building sensible plants, and that's where the industry has come on huge amounts in the last sort of 20 years. This industry didn't really exist more than 20, 25 years ago when the Germans started their first foray into it. And actually over that time, people have developed sophisticated separation mechanisms for the front end to sift out the crockery and the cutlery and the Rolex and everything else. People have then developed treatment post-digestion to make sure we're not returning plastics to fields and so forth. All of that has come on hugely, and so new generation plants can cope.
Okay.
And then it's just, there is a scale at which anaerobic digestion works because it is more complicated than a solar panel, no question about it, right? There's lots of moving parts. We have a brilliant engineering team who jump on all sorts of issues that valves that stick and augers that break and upgraders that have technical faults and software issues. And
an auger, what's an auger?
Oh, a circular thing like a screw that pushes stuff through a pipe.
Very good.
But all of this stuff breaks. And it always breaks on a Friday afternoon before a bank holiday weekend. So I'm incredibly grateful that we have a massively dedicated engineering team who will jump all over it and work all night to get it running again. But yeah, you do need that. The other benefit, of course, of having a growing industry is you get that depth of knowledge, right? You get that talent across the industry. And we talk to all the other people who operate plants. We share spare parts. There is an ecosystem that has developed around it. And you can see that in France, you can see that in Germany, you can see that in Italy. That will grow up in places like Poland and elsewhere. And then further around the world, anaerobic digestion can be very, very different. So in places like India and China, you often have small home digesters that just replace the cooking fuel. That's a very, very different model to the one we've been talking about today, but also a perfectly valid model, Yeah. And in the US, there is a massive untapped market of organic wastes that a couple of players are now going after, because you can just see there is a huge potential for organic waste.
It's a fascinating part of the sort of wider transition. How does this all work? It slots into the agriculture massively.
Yep, massively.
So a really interesting story. Maybe the one thing we've not talked about, really, we've implied it, but we haven't talked about it, is subsidy. Obviously, the sector has been subsidised.
Yep.
And I think there have been some earlier subsidies that were more generous, and then that subsidy scheme has changed, and that's kind of affected the pace of the industry. So, as someone who's in this side and who sees it, how would you describe kind of the journey that the sector's been on?
So the sector's been on a journey in two ways. One, scale. So subsidies were originally targeted at small scale plants, and they've actually now refocused to bigger, more efficient, more economic to run plants where you can afford to install better monitoring, better engineering, et cetera, et cetera. The second one is, as you say, subsidies have come down over the years. Here in the UK, the subsidy mechanism itself effectively ticked down automatically as build out happened, which is quite a clever little sort of cost control mechanism. We think, and we thought 5 or 6 years ago, that there would be a market for unsubsidized. As we've had that discussion around, the one costing 40 plus 20, 60 pounds or euros a megawatt hour, and the other one costing around 100, and that gap narrowing. And there being lots of people who actually don't want subsidized gas, or who don't want to be seen to be supporting intensive livestock ag, because that's not their business, right? They don't want to be decarbonizing livestock ag if you're making, food or pharmaceuticals. Well, maybe if you're making food, actually. And then the European Union has set itself some really ambitious targets. Their 35 billion cubic meter target is roughly the equivalent of 1,000 terawatt hours for Europe. We probably won't reach that by 2030, but got to start somewhere.
It's chunky.
And ultimately, we can't afford to subsidize the energy transition. So what people are moving to now are different models, like obligations. So obligation is where I tell you as a fossil fuel supplier that 5% of your fuel needs to come from biomethane, and you then have to go out and buy that. You'll look for, obviously, the cheapest you can find that meets the criteria I've set you, and you'll spread that cost over the remaining 95% of whatever you supply that isn't biomethane. And that's the model that we've gone for with aviation, the obligation to use SAF, sustainable aviation fuel. That's the model that we've gone for in a number of vehicle fuel applications across Europe. I think that's probably the model that we'll get in the UK. At the moment, we still have a subsidy regime, runs till 2030, and supports biogas plants that are built in the UK.
So it was linked to the RHI.
It was the RHI. It's called the Green Gas Support Scheme now.
The GGSS?
Catchy. Yeah.
Okay.
And it's actually supported by a levy on gas suppliers.
Okay.
But in effect, what I think we'll probably end up with is, like much of the world, an obligation of some description. If you're supplying fossil gas, then you're probably going to have to end up sourcing 5, 10, 15, a rising percentage of green gas. Separately to that, certainly our business model is predicated on finding people who want to make that transition and want to demonstrate they're making that transition sooner, such as AstraZeneca, who say, no, fine, I want green gas, where I can demonstrate that I've paid all of the production costs of that and had it sleeved through, as it's known, to my door by a gas shipper through the existing network. And as a result can say, I'm 100% low carbon, zero carbon, because I've paid for this gas to be made.
Okay.
And so we're in discussions with, if you like, the follow-on customers, a whole raft of people from the food industry, from pharmaceuticals, from data centers, around that model.
Okay. One final question. Let's say tomorrow, not that I have the power to, but you become in charge of the energy systems in Europe. Finally. What do you do? What's the one change you make?
That's an interesting one, because one of my biggest bugbears is that we have such a poor opinion of nuclear in Europe. When in fact we're going to need it to maintain our industrial advantage, and we should actually have the state building it. What I would do in a wider, I mean, let's go away from biomethane for a moment. What I would do is I would reawaken the spirit we had in the 50s, 60s, and 70s, where we built things as a nation here and elsewhere, because. And you know, this is going back a bit. In the 80s and 90s, we privatized all of our energy and sewage and telecoms and so forth industry. The only reason we could do that is because we'd spent the previous 40 years building them up. And that's the place for government, is building stuff like that up. Okay, HS2 hasn't been the railway that we built here that's going to be more expensive than any railway in the world. Hardly something to be proud of. But we can do infrastructure projects well. And the sort of infrastructure projects I'm thinking about here are not biomethane, because you just need to set the right signals for biomethane and it'll happen. We've shown it'll happen across Europe in many, many countries. But tidal, large-scale hydro storage, networks, offshore cables, nuclear are all the sort of things that have very long lead times, very long paybacks, some degree of risk attached to them in terms of are we going to need them or not. That's where I think it would be brilliant if we could get government to come in and do a lot of that, because then in 20, 30 years' time, our children and children's children will go, oh, great, look at all these assets. We can privatize all this.
What are we doing with our working lives if not to make something that can be privatized in the future?
Or not.
Yeah, I think there's some flavors of that I really like, particularly around when you look back in history at sort of the efficiency of some of the projects that were built 50s, 60s, 70s. There's a lot to be commended there.
Oh, yeah.
We could look.
I mean, we knocked out coal-fired power stations at a rate of, one every 2 months or something, and they were all exactly the same. If we could build nuclear like that now,
it would be a different world. And if you look at China,
world, right?
They are doing that.
Exactly that. Exactly that. And if you want to build a tidal range in the Severn, and I have no particular opinion about whether it's a good thing or not, but if you want to do it, it's got a 40, 50, 60-year payback. Guess who should be funding that, right? Similarly, if you want to build big energy storage in Exmoor, which was on the cards when they built De Norwig in Wales, the big energy storage. Well, if you want to do that, it's again another one of those things that probably really good for the Southwest, really good for the energy system, but it needs government to do it.
It does need some intervention. Yeah. Let's take ourselves back to biomethane and wrap up. So you started at the start and said, look, people need to not think about it as niches, but they need to think about it in the broader context of what it could do. Where am I on that? I think in parts, I really see the strength in some niches around the farming and around the sort of waste products, then goes to be fertilizer, and that piece around I'm going to use fallow again in the wrong language, but essentially this rotation, that really appeals to me. I think maybe the thing I'd say is that when we, with all of these things that are changes in the energy system, the thing that really sort of shines through is volumes delivered. Can you get volumes delivered? So I think maybe I'd say from 5 terawatt hours today, if you can show that 10 to 15 terawatt hours, then I'd be much more, I don't matter, but like people will be much more inclined to believe the 60.
Absolutely, but it took us probably 6 years to build out the 5 terawatt hours.
It's a really interesting space.
It's not something that we've demonstrated before we can do it. It's the reason it didn't continue like that is because we stopped the subsidy regime and we didn't replace it with an obligation.
There we go. I think listeners will really enjoy a very candid approach to this and will have learned something along the way. So,
Philip, listen, thanks for taking the time.
Thank you for coming on.
Cheers.